so cringy.
Hey, what's up, y'all?
What's up, D?
Chilling. So we can go ahead and get started. We're starting a bit late here, and and to make sure you're aware of where I am, I'm not here to try to argue with you or anything like that. Uh, uh, you could sum up my position as trying to learn. So Horry Sheet here said that some of the conclusions I was drawing was inaccurate, that the information I was getting from the flat earthers I was getting it from were not accurate, but that you're the man and you
I
have
don't
the
know about
answers.
that, man, but maybe I can answer some of your questions. Let's give it a try.
Sounds good. So I pretty much have three basic subjects
All right.
I want to touch on, and I'll just
Sure.
give you the. Go ahead.
First of all, are we recording, D? Are you recording?
Yes. I mean, the reason was we are recording. We could all use the recording and such. Correct.
I'll just get. You know what? I was gonna get the recording from you, but let me see. I just may as well just record mine as well.
Sounds good.
Let me set it up real quick though. I'm gonna turn this off the studio. All right. So let me just do this. I'll record it like this. Bear with me. Because we didn't, I was telling David I didn't know if we were going to record this or what, but I wouldn't be surprised. So
I
here
thought
we
we were
go.
just having a conversation. I don't know you. I've never seen anything you've done. Horry said you're a friend of his, that you had some concerns about my videos, and I thought we were just having a discussion. But go ahead. You can record it. Yeah.
All right. I'm just going to repeat what David said. He wasn't aware that this was going to be recorded. So this was supposed to be a casual conversation, now going recorded off air. So let's continue, guys. Darryl said he's here for just to learn. I said David Weiss is the man, and he's got a lot of questions to ask David. And
Sounds good.
I'm not at liberty to really answer them. David knows more about it than me. So here we go. Here's the conversation.
Sounds good. And basically, I have three different topics I want to touch upon. The first one is the solar filter video you did, the D16 solar filter. The second one is about flat Earth itself, as far as dimensions of the sun and the moon and things like that. And the third is about rockets, how you were saying that CGI rockets and rocket assisted blips. So it's really not necessary to know anything about me. I guess we could. I'm open to accepting questions from you as well,
Sure.
just to be sure. But the first thing, the filter that you use in that video, and you're familiar with the video I'm referring to, correct?
So you're referring to I captured the sun fading out 4 times, and
Yes.
I'm just going to preempt you here. The first 3, the purpose of the film was just to watch where the sun goes from an elevated position when there's no low-lying clouds.
Mm-hmm.
And you need a elevated position, you need a clear, super clear day, you need extremely low humidity, which usually means a colder temperature, and you need a 4K camera to film it. And so I never was trying to prove the size of the sun or the sun shrinking with the first 3 videos.
Well, no. Well, I'm talking about the foot video. I'm talking about the video I looked in.
Hang on. Let me finish what I'm saying. And all of the ballers, with respect, all they're screaming is solar filter. You're not using solar filter. Use a solar filter. Use a solar filter. And they think I'm trying to make a video about the size. So I finally said, okay, you know what? Let me get a filter. And I got an ND16. I don't know crap about solar filters, all right? And I put it on, and I knew immediately that it wasn't dark enough for what they wanted. But I put it on anyway. It helped with the glare a little bit. And in my video of the sun fading out, I took a couple still shots, and I said, to me, it looks like it's getting smaller. And that's it. But that wasn't the point of the video. I do not claim that the sun is getting smaller. And that's it. I actually believe that it's getting smaller, but I have not captured it with a solar filter. Now today, I actually used a real solar filter. I have a solar filter that I had for my P900, and I cut it out and put it in one of the lenses for the drone. And what it does is it makes it look like the sun sets. The sun, you actually see it disappear from the bottom up, and then it's gone. Mm-hmm. And I quickly took the drone down, pulled the solar filter off, put the drone back up, and the sun was still there. Okay? So the problem with the solar filter is assuming that the sun's light travels for billions of miles and millions of years, when it doesn't, in my opinion.
Okay.
The throw of the sun's light is very limited, and when you put a solar filter on, you limit that throw even farther. So the only time that you would ever see the sun shrink is those last couple of degrees, maybe 2 degrees, 1 degree, 3 degrees, whatever it is, of its apparent drop to the horizon. At that point, perspective has used up all the perspective, and now you're going to see it shrink away. The problem with that is it's going farther away through the densest atmosphere, and the atmosphere is going to eat it before it turns to nothing. And that's what my videos were proving. My videos prove that the sun doesn't set, it disappears into the thickness of the atmosphere.
The light doesn't shine forever. The sun's light does not shine as far as we think, and the solar filter is limiting that even more. And we still get the sun is disappearing from the bottom up, but that's only due to perspective.
Right, and I just uploaded a video 5 minutes ago showing that again, how that.
And in that video you show the one with the solar filter too, or just without the solar filter?
No, well, that one I did not because there was the cloud. It was a little hazy, and there was some clouds, and the sun wasn't that bright. I went with no filter at all. I have a whole bunch of lighter filters, but I don't think I had any filter on that one because I didn't want to limit the light, because putting a filter on makes the sun disappear that much faster. I'm showing that without a filter, the sun gets eaten by the sky, the air. Yeah. And if I put a filter on, it gets eaten. It disappears sooner.
DITRH, what do you call that atmospheric layer, that black layer of atmosphere that eats the sun? What do you call it?
So Darryl Berry?
That's
Berry,
right. That's right.
Yeah. So when you're looking, let's say.
Well, if you don't mind, before we go to the next point, can I just make sure I just to clarify that I understand what you said so far?
Sure.
So you put the solar filter on, a proper solar filter. So a proper solar filter.
And it blacks out the sky. The only thing you can see is a dot.
Okay. And when you put that solar filter on, that blacks out the sky, where all you see is the orb of the sun, you did see it disappear from the bottom up.
Well, here's the problem.
Well, that was a question. That was a question.
Yeah, no. Yes, I did.
Okay.
Here's the problem. The problem. There was some spotty clouds in the distance. Some thick clouds, and it could have just been being eclipsed by that cloud. And then when I went down and came back up, it was now below that cloud from my vantage point, and it was back there. The only way to tell if that's what happened, if it went behind a cloud layer, which it did, is we need 2 drones at the same time filming, one with and one without a filter. I can't tell what it went behind, but the filter made it.
Let me make sure I'm understanding properly. So you're saying that you're not really sure if it was the horizon that made it go from bottom up or a cloud?
No. It definitely wasn't the horizon. It was well, I call it the atmospheric deck, or the opaque atmospheric deck. It was either that or a cloud even closer. I don't know, right? Because as it's moving away, it's disappearing into that deck. If you darken, and if you put a real solar filter on, that's taking so much light out of the picture that it might. A lesser cloud might black it out. It might, I'm trying to get my words here.
I understand.
Let's say a cloud that would only take out 50% of the light, so you can still see the disk. But if I put the lens on it, it's going to take out 100% of the light. So it would get eclipsed behind that.
I see. I'll tell you what then. Why don't you on the day that's really clear, where you know it's clear and there's no clouds, would you go ahead and put the solar filter on then, and then fly your drone up and record it, and then we can talk about that again, because apparently since there were some clouds, we can't really get a solid confirmation on that.
Even better. I now have 2 drones. I bought a second drone so I can film simultaneously.
There we go.
And
that's
without
beautiful. That is perfect. So I'll tell you what. Soon as whenever you have a clear day, when you can do that on a clear day where you know there's no clouds, you can fly boat drones and so forth, it'd be a small thing for us to come back together and talk about that again.
Absolutely. Absolutely.
So awesome. And let me just ask a question about that first video, because you called that first filter a solar filter in your video.
I'll stand corrected. I don't know, and I said earlier, I don't know crap about solar filters. It said solar filter. It was the highest one I could find.
It did say solar filter when you bought it?
Yeah, it said a solar filter on it, but it wasn't for photographing the sun. It was just I forget the exact word.
May I see that link? Will you get that link, please? And I can see the link where you bought it from that said it was a solar filter.
I bought it on eBay. I don't even remember what it was. I can look it up, but what it was is I didn't do a lot of research. I had a bunch of filters. I have a 4, an 8, and a 16. Okay.
Understood. You didn't do a lot of research. You didn't know it wasn't a solar filter.
This is a 64. That's 4 times darker. Let me get it. And then when I got it, I immediately realized it was no good as far as what people are looking for. Mm-hmm. And I actually took the solar filter I had for my P900, which I'm done using, and I cut it and put it into the ND4 lens.
No problem. Well, there's some lack of clarity about the clouds, and we have an understanding that you'll do it on a clearer day with the 2 drones, and we can come back again at that time. So that's perfect. And if I could, let me ask you some questions about the flat Earth itself, because one of the issues I have is I take data that flat earthers give, like they say that the sun is this big and is this far away, or is this small and is that high, and so on and so forth. And I say, well, okay, if I work this out, that doesn't add up to what I'm seeing here. And then they say, well, that's because that's not really the way it is. That person doesn't know what they're talking about, or they're from that other camp, or they're not a real flat earther, and all of this stuff. So I've been wanting to talk to somebody who has been identified as a real authentic flat earther, such as yourself, who can give me the real answers. So then when I go ahead and try to figure out what's going on, then I can actually come to a conclusion. So let me ask you, what exactly is the sun? Like, where is it? What's the distance from the sun's surface? What's the size of the sun, the shape? How does it move? Because I found a video by D. Marble and Max Malone. Seems like not everybody's familiar with Max Malone, but I'm sure you're familiar with D. Marble.
Yeah,
and
I know both of them.
There you go. And I also found another video by Rob Skiba that showed the same motion of the sun, which I linked to Horry earlier, and he described it in the description as the moon. So all 3 of those say the sun and the moon go around over the top of the surface of the Earth. So so I want to ask you, how does the sun? Where is it? How does it move, and so on and so forth? And I'll listen.
Yeah. So the real answer is, and I'm going to start. I'll back into it the best I can. Is the only thing anybody, yourself, any scientist, anybody can really say about the things that we see in the sky is that they're luminaries. Okay. There's nothing else we can say. We don't know how big they are. We don't know where they are. We don't know how far they are. We don't know We don't know anything other than their lights, right? There's no pictures of planets. The only, we look through a large telescope, super zoom lens, whatever you got, at a planet, and we see a light. That's it, a light. And then NASA and Disney show us these images, these paintings, and like, oh, this is the planet. Just like they just found an underwater lake on Mars. They discovered the other day. Okay. But meanwhile, the scientists in Hawaii, as the lava comes out of the lava lake and goes past the caldera, they're like, we don't know what's going on. We don't know where it's going. We don't know how high this lava lake is. We don't know where the lava is coming from.
They don't know when it's going to stop. We don't know if it's going to destroy the whole island. Nothing.
And they're here. And meanwhile, they're looking at the sky and they're coming up with these fantasy stories. Okay. which are just utter nonsense. So, a lot of flat earthers have a lot of ideas. Mm-hmm. Dave Murphy put out a video early saying the Eratosthenes, saying Eratosthenes proved the Earth because of the angles and shadows. And he goes, well, if the sun was 3,000 miles high and 700 miles wide, or whatever it was, you get the same results. Well, guess what? You can get the same results with a closer and smaller sun too. Mm-hmm. The problem you have there is if you have a really close, small sun, like I'm in Connecticut, and if the sun is really that small and close, how are people in Florida in the same time zone seeing the sun, right? It wouldn't work. It would be on the horizon at best for them, when it's high noon for me, and that's just not the case.
In other words, you're saying if the sun was close, like they were saying, it wouldn't work either?
It doesn't work. Then it doesn't spread across the Earth.
Okay.
But the way I see it is and the sun and the moon and the stars are all in a unique position based on each person. Like if you and I were at the beach watching the sunset and you're a mile down the beach, the sun is going to skirt across the water right to your feet. There's going to be a line across the water to your feet. And there's going to be a line across the water to my feet. I can't see your line. You can't see my line. We can't see the sun in the same position. And here's the best way that I can describe how we see it. I call it the reflected sun or the apparent sun. And again, this is my opinion. There's lots of evidence showing that this is the case. But again, all we know is there are lights in the sky. Here's an experiment you can do. You got a nice big room, and you divide the room with a blue sheet, like a bedding sheet. It's just in your mind, and it's kind of very sheer sheet, right? So you can almost see through it, and that's the sky. So you got your back to the wall, and you're facing the sheet, which is cutting the room in half in front of you. Okay, you with me? I'm drawing a picture.
Okay.
Here, and I'm on the same side of the sheet as you, and you're on one side of the wall, and I'm on the other side of the wall. On the far side of the room, on the other side of the sheet, we have a bright light, a sun. Okay. In the middle of the room, facing, just the light.
Understand? So the sheet is in the middle between us. I'm on one wall. You're on the other wall.
We're
on the same side.
We're on the same wall, but we're separated by 20 feet.
Okay, I got you. Okay.
And we're both.
You're both looking at the light that's behind the sheet.
Okay. And the light is behind the sheet.
I got you.
The light is 50 feet behind the sheet.
Okay.
Okay. On 50 feet away. So you're gonna draw a line from your eyes to the light, and that line's gonna go through the sheet to the light, and right where that line hits the sheet, that's where you're gonna see a bright light on the sheet. You don't actually see the light. You're gonna see the light on the sheet, right? You know what I'm saying?
So that's your sun.
You draw a little sun there. I'm gonna see the light on the sheet in a completely different spot, and I'm gonna look over at you and not even understand how you see it on that position. It makes no sense to me. Okay, and that's how I believe that we all see the sun, the moon, and the stars. But just stick with the sun right now. So we all see them in our personal viewing dome. Okay. So again, how does that work? I have no idea. But you can create this, in an experiment with like bubbles. Like if you get a soapy sink of bubbles and then hold a light over it, hold a pen light over it, and you'll see that the light has that light is on a different position for all of them. The ones on the left, it'll be rising, and the ones to the right, it'll be setting on the dome. I actually took an AE map, and I have like 20 half dome glass domes, and I put them all over the map, and then I ran a light by it. And as I came by the East Coast, you could see the shadow lifting from inside the dome. And then when I got to around noon, the shadow started lifting over in California, and it worked kind of really good. I'm trying to film it, a better filming of it, but that works.
So let me make sure I understand properly. I'll go backwards, and you can make sure I got to understand what you said. So, like using the example, there's a wall behind me. I'm standing by. I don't know if you can see the doors, but I think you can see a door on my right, a door on my left.
Yeah, two doors. We see two doors.
So one door is where I'm standing. The other door is where Horry's standing. There's a sheet right here. My computer screen is the light. I'm going to see the light on the sheet in one area, and he's going to see the light on the sheet in the other area.
A slightly different area.
Okay.
Right.
Now, and what you're saying is the sun, the moon, the stars, the planets. All anyone can know at this point is that they're luminaries. No information on exactly what they are, where they are, anything like that. Just that they're lights.
That's all we can say. I mean, what else can you say for sure about these things in the sky? You haven't been there.
Okay.
And in my opinion, no one's been to any of them.
Now let me ask you this. Now I understand what you're saying, and I repeated it back so we can make sure that I understand what you're saying. We're on the same page. Now, the thing is, like, let me give you this link here. This is from This is a link from February 19th of 2011. I'm going to put it into the Skype chat there so y'all both can see it. And just give me a moment, and I'll give you a moment, and you can let me know when you have that pulled up.
Well, go ahead. I'll look at it in a second. I'm just trying to find something for you as you're talking. Go ahead, then I'll look.
Okay, no problem. So when you pull up this link, what this link is, this is one of the websites. The reason why I got this link, and I'll link another one as well, and I'll describe what both of these links are, because these are links that I use, or these are sites that I use, because I consider myself something of an astronomer, and I have my own telescope, which I guess I could break it out the box and show y'all, but I have a picture of it somewhere else too. And I use this site, these two sites here, timeanddate.com and csky.org, to find out when a planet will be here, or when the moon will be here, or when a solar eclipse will happen. Now, if you look at the first link I linked, it is from csky.org from 2011, February 19th of 2011. And if you scroll down on that link from Astronomy Calendar, February 19th of 2011 is when this link was there. It was saved in archive.org. And you scroll down, you'll see for July 27th, it says total lunar eclipse. The eclipse will be visible throughout most of Europe, Africa, Western and Central Asia, the Indian Ocean, and Western Australia. That's on csky.org from February 19th of 2011. If you look at the second link I gave you, that's from timeanddate.com, November the 17th of 2012. This also gives the July 27, 2018 lunar eclipse. It shows the locations. It shows a map. That map matches the locations that are given on csky.org. And if you look at the csky.org link, there's a link for there's a link to NASA. It says NASA map and eclipse information. And I click on that link, it opens up a PDF file. And this PDF file, when it opens up, and you can click it yourself and open it up yourself, this also gives the details for the total lunar eclipse of July 27, 2018. It gives the location, it gives the exact radius of it gives everything. Well, let me finish now. I'll let you finish. So let me finish. So my point is, science gives exact dimensions for the sun, exact dimensions for the moon, exact dimensions for the Earth. Those are luminaries, and also all the planets and so forth. But right now,
suppositions, though.
Well, let me finish. I know it's kind of long-winded. But let me finish, and then I got to ask my question. Because I'll let you finish, and I repeated everything back so you can know I was really listening. So please listen to what I'm saying as well.
You got it. Sorry.
So I have a link here from 2011 and 2012 from NASA, from csky.org, and from timeanddate.com, and these people present exact dimensions for the moon, the sun, and the Earth. And using this information, they predicted a lunar eclipse, a total lunar eclipse, the exact time, the exact date, the exact location, the exact everything. And it was seen recently. I'm sure y'all must be aware that it was a big deal. There was a lunar eclipse recently. You could even see videos of it on YouTube. People were live streaming it. So you said that these things are just luminaries that are like, I guess, like unknowable to some extent. Yeah,
No.
these people present some very exact dimensions.
That's where you misinterpret what was actually just said. It's not that we don't know when these things are coming and what's going to happen. We've been knowing this for, David would agree. We've been knowing this since thousands of years. Like, we've been able to predict eclipses. They've
been predicting eclipses for thousands of years, long before anyone ever thought of the ball Earth. I mean,
yeah.
All of the ancient civilizations, they all had flat Earth maps, and they planned these things. Now, I'm not the right guy to ask. Jaron is really good at this, but I believe there's like one guy responsible at NASA for predicting the eclipses, and he uses I think he uses a method that the ancients used, or whoever used it. It's based on a flat Earth.
My understanding is you're not the one to ask. You don't know about this.
I'm not the one to ask. But here's
no problem.
But that's a fact right there that you can't really pass up. We've been able to predict eclipses for a long time. So all of this stuff, whether it's a ball Earth they're saying they're getting it from, obviously we were able to tell that this can happen, but they were getting it from our ancient civilizations that had a flat Earth model.
Let me jump in here. Let me jump in. you throwing and saying that we have exact sizes for the distances for the moon and everything.
Oh, yeah.
But you can change all of those. But if you double the size of the sun and double the distance, everything, we would never know the difference here. You just double everything.
Well, maybe I'm not being clear about my point. My point is this. They give us exact sizes for the sun, sizes for the moon, sizes and dimensions for the earth, exact rotations and revolutions, exact, to the point that you can put it in a computer. And let me finish it. Put it into a computer simulation. And using these exact measurements, it all adds up to match up to when the solar eclipses happen. So it's clear from the information that they give that they're not just getting this from the ancients. You can use the data that they give for the sun and moon and the earth today, those exact dimensions and sizes and rotations and revolutions, and how long the earth takes to go around the sun and how long the moon takes to go around the earth, and all of that stuff, and it matches up to what we see when the solar eclipse comes.
You can make math do anything you want. You can make it. You can just. I know the next a week from tomorrow is going to be Monday. Mm-hmm. So I can do math. I can give you math and stuff to show you that 2 weeks from tomorrow it'll be Monday also.
But can you, given your flat Earth knowledge, predict when the next solar eclipse will be 7 years from now?
I'm not the guy to predict that. I don't know. But
so you said Jeranism could do that? Is that that's what?
No, what we're saying is you can do it on a flat Earth cosmology, Darryl. We can do it on a flat Earth cosmology.
I'm asking you to do that. Show me that.
Can you do that?
I don't believe in the flat Earth, so I can't do that. That's why I'm looking at you.
Can you not look at csky.org and show us on any model, any kind of way, exactly when an eclipse is going to happen and why and when, based on like just a graph? Like, this is what I'm saying. Like, they're giving us data. That data matches our reality, but they're getting that information from either cosmology, a round Earth with its timing, or a flat Earth with its timing, because the flat Earth cosmology is like clockwork as well.
Exactly. That's what I'm asking. That's what I'm asking. So tell me the timing of the flat Earth. That's what I'm asking. Beautiful.
We're not the
tell
experts.
Me the timing.
We're not the experts, and you're not either for the heliocentric model.
Okay. So who is the expert for the flat Earth?
You're asking a great question. I can't answer it, but what I can answer is the following. We're told that a lunar eclipse is when the Earth shadow hits the moon, correct?
Mm-hmm.
Okay. There's been many documented eclipses, Solenian eclipses, where the observer that's seeing the eclipse not only can see the sun and the moon above the horizon at the same time during the eclipse, the shadow, in quotation marks, doesn't come in from the bottom of the moon. It comes in from the top. Okay, so you can say refraction, the moon is that the sun and the moon are actually below the horizon and you're seeing them, but that wouldn't explain the shadow coming in from the viewer's point of view from the top. Okay, it's clear that it's not a ball Earth shadowing a moon. The other thing is because you can't in a lab get models and lights and recreate that in any way, shape, or form, where the observer on the middle ball can see both balls, the light and the moon, and the shadow would come in from the top, and they would both be above his horizon. You can't model that. Another thing you can't model is you can't take a dusty, dirty rock and light it up like the moon without a hot spot. The moon, on a full moon night, on a clear night, you can read by it. You can read a newspaper by it. It casts shadows on the ground. It's so bright. You can see your moon shadow. And if you know
it casts a cold light as well.
Right. And so it's throwing so much light, and then we watch the moon missions, and they're on a dusty, dirty ball, okay?
With shadows on it.
Yeah. And if you know anything about how light travels, the inverse square law, it would have to be, we did the math, it's ridiculous. It would have to be like 180,000 times, don't get me wrong, it might even be more than that, brighter than we see it here on Earth, on the moon. And none of that makes any sense.
All right. Now, let me just make sure I say something. Like, I understand that the light reflecting from the moon and stuff, you're saying it doesn't make any sense to you. I understand that you're saying that you don't understand the. I'm familiar with the eclipse you're talking about. I don't remember how to say the exact name, Solenian eclipse. But you've already showed me with the solar filter that it could simply be that you're not understanding it. Like I'll look into it briefly, but I haven't looked into it deeply. But I could show you now how somebody can see the sun and the solar eclipse. They could simply be standing on that side of the. I have to click it so I can see what I'm showing y'all. They could just be standing on this side of the planet, so they can see the moon over here and see the sun over there. But as far as the movement of the shadow, I would have to.
How does the shadow come in from the top of the moon?
Again, I would need to see for myself that the shadow actually moves in that direction, because you've already shown me that some things, you said it yourself, you don't understand the sun and the moon. They're just luminaries.
Sure.
And you've already shown me as well, like earlier, sometimes you don't research things as fully as I would, put it that way, because you called that a solar filter, but it wasn't a solar filter. But as you said yourself, you didn't really do a lot of research. You didn't know it wasn't a solar filter. So I'm not going to just take your word that that's the way it works. But what I can do,
you should do that. I appreciate.
But this is what we can do, though. This is what we can do. We've already agreed that on a very clear day, you're going to get your two drones, put one in the solar filter, do it simultaneously, and you'll have that. And this is what I will do for you. For when that day comes, I'll do research on the cellular kind of eclipse, and I'll explain to you exactly how that will work on the round Earth. So you'll have something you'll bring to me, I'll have something I'll bring to you,
That's great.
and then we'll do that.
Can we talk about the stars and the sun?
Okay.
So when things are moving into the distance, perspective makes them smaller, correct?
Yes.
You understand about the angular resolution limits of our eyes?
Yes.
Okay, and then anything under, I think it's 0.2 degrees is invisible. We can't resolve it in our eyes.
I don't remember the exact amount, but I know there's a point.
I'm pretty sure that's it. It's so small that our eye can't resolve it.
Mm-hmm.
So, do things get smaller consistently, or do they stop getting smaller after a distance?
Things get smaller consistently. Yes.
Okay. So we're told that the sun is one of those big blue yoga gym balls, the big ones that you can't wrap your arms around, basically. And the Earth is a pebble next to it, right? Mm-hmm. Approximately.
Basically, yeah.
Okay. So we put the pebble down on the ground, and we hold the gym ball an inch above it. Okay. Mm-hmm. And you're on that pebble, and you look up into the sky. What are you going to see? You're going to see the sun from horizon to horizon. Pretty much. Agreed?
That sounds reasonable to me.
Okay, so now we're going to move that ball 93 million miles away, mm-hmm. the sun, mm-hmm. and now the sun reduced from being everything in the sky to the size of a dime held at arm's length. Approximately, the sun is around the size of a dime held at arm's length. We'll call it a nickel, call it a quarter, I don't care. Yeah, but if you hold a coin at arm's length, that's approximately the size of the sun. About.
Well, I mean, I never did the coin thing, but we're on the same page. It's pretty small in the sky, I would say.
So
I'm with you.
So if I doubled the distance of the sun, remember, it went from horizon to horizon to the size of a friggin' dime held away from my eye. Mm-hmm. If I doubled the distance, how much smaller would it get?
Well, I don't know. I mean, there's actually a formula.
Do you think it would be visible?
But, yeah, that's a good question.
Let me give you an example.
Hold on, you can ask a question in a minute. So answer my question, then I'll let you can repeat.
But I told you I don't know. I was about to.
But using your common sense and what you said earlier is that things consistently reduce over time. Mm-hmm. So when it went to 93 million miles, it went from the horizon to horizon to the size of a dime. If I doubled the distance, it has to reduce more. How about this? If I 8 times the distance, do mm-hmm. you think you could see it?
All right. This is the thing. This is where we're having a disconnect of understanding on this point. The fact is, quote, common sense may not be relevant in these situations, because common sense is really a function of our current understanding. And a good example is that's one reason why I asked that first. When you got that filter, you thought that filter was sufficient, but you later learned that wasn't really a solar filter.
No, I didn't. You keep bringing that up. I bought a filter. I wondered if it was good. The second I got it, I realized it wasn't. What's the problem?
You called it a solar filter. It wasn't. And,
It's a solar.
and you're
It's
just
a solar filter. It's not the kind you want it to be.
It's not the
but
kind
it's
of
a
solar filter you want. There's hundreds of solar filters.
all right.
Yeah.
Let me show you something then. Let me show you something.
I googled solar filter DJI drone, and that's what I got.
Okay, then that means that you didn't do like you said, you didn't do a lot of research. Let me show you something. Let me show you something.
Glare, and that's the strongest one I could find. And the second I got it, I realized, and I kind of knew it before I even ordered it, but I was confirmed that it wasn't the kind of solar filter that all of the people,
all the ballers want it to be.
Okay, let me show you something.
Can I say something real quick, D?
They didn't do the research. It's that I got it, and I knew what I got, and that's it.
Well, let me show you. Let me just show you 2 links before because I actually did research on the filter.
I can't get the links for some reason.
That's fine. Well, it's not necessary. I can get you the link to the actual manufacturer of the filter because I looked at the filter that you had in your video, and I took the effort to actually go online and find where that filter is sold. Just give me a moment and I'll find 2 links for you. One moment, please.
Well, he can't see it right now, but what I'm trying to tell you, D, is that he's not trying to prove any other thing in those 2 videos or whatever he put up. The first few videos is other than the sun's light doesn't travel forever. He's got the sun over the horizon, not dipping down, disappearing from view. It just fades out. That is mind-blowing to me. That should not happen on a ball Earth. I don't know. I don't understand why you have to attack him about what solar filter he's using.
Yeah,
his main purpose is that.
This is the problem. This is the problem that I fell into. I fell into the problem where all of the people that can't drop the solar filter conversation, which has nothing to do with what I was filming, I fell into it and said, okay, I'm going to put on a solar filter. And I Googled solar filter DJI Mavic, and what came up was a PGY TECH G HD ND64. I looked at my other filters. The strongest one I had was an ND16. I'm like, let me get this one. The picture looks kind of dark. I'm looking at it. It looks like a nice dark filter. I got it. I looked through it. I'm like, that's not going to be good enough. But let me see what it does. You know what? Cut out some glare. It was it actually helped, but in some situations. So that's it. I shouldn't even have responded to all of these comments that had nothing to do with what I was filming.
Okay, no problem. But let me show you something else then. So we're gonna just leave the solar filter alone. But I'm let's go to this video by Rob Skiba that demonstrates the point I was making that depending on your previous understanding, common sense may not play a factor. So in this video, and of course you could take a moment later and look at the whole thing, but I'll just give you the general idea of what's going on. So what happened is Rob Skiba made a video a few years ago, or however it was, and he basically, what happened is NASA put out a photo of a satellite, like they sent out a satellite, NASA or Japan, I don't remember exactly, but you could see the video. But they sent out a satellite, it was like 1,000,000 miles away, and they took a picture of the Earth.
Right, he misdescribed the size and what size.
Exactly.
And he corrected himself after that.
Yes, he did.
No.
Yeah,
well, you're missing my point.
You're
missing my point. You're missing my point.
All right.
Hold on, let me finish.
Go ahead.
You're missing my point. My point is this. So y'all know what I'm talking about, though. But my point is this. He used his common sense, and he decided that if you were on the moon, the Earth would take up the whole sky. And he decided that if you were really 1,000,000 miles away, the sun and moon wouldn't look like that. That was his common sense declaration, and he said this proves that NASA is horse shit, and all the photos it took from the moon is horse shit. All that stuff is horse shit. You could, and like you said, he did debunk himself, and I commend him for that. But my point is, using his common sense, he came to that conclusion. But well, let me finish. Let me finish. And when he actually did the experiment on perspective, he found out that in reality, his common sense was absolutely wrong, and in reality, doing the experiment, his perspective matched exactly what the satellite photo, the perspective was from 1,000,000 miles away, and it matched exactly what the perspective would be from the moon viewing the Earth. And he did the experiment himself. You can see it. So that proves right there. So going back to the the size of the sun, there's no. I'm not going to sit here and guess at what size the sun will look like. It's not a common sense thing, but there is a formula for perspective that you can find where you can actually put in the calculations for the size of everything and the distance, and it'll give you the exact angular size of that object. So you can find it out exactly. And that,
All right, hang on. So you didn't let me finish my point before, so I'm going to finish my point now.
Okay.
And you're saying, Rob was talking about something that he couldn't view from Earth. I'm talking about something we can view from Earth, and what we're told by the people that you think are telling you the truth.
Okay, how can we view that from Earth? Well, let's take one step at a time. How can we view that from Earth?
Stop.
Oh, okay.
Finish what I'm saying.
Okay.
We're here on the Earth. We can see the sun. We're told that the sun, in relation to the Earth, is a gym ball to the pebble. Okay? That's what we're told. So we can, without guessing, say if the sun was a mile above the Earth, we would only see the sun. It would fill the whole sky. That's not an opinion. That's a testable fact. And we can do it by getting a friggin', a pebble and a gym ball and, put a little camera on it, whatever. You can prove that. And we could also prove that the sun is the size of a dime held at arm's length just by looking at it. All of these things are not opinions. These are facts. And nobody's going to argue. Nobody is.
No, what I was saying, we can't see from Earth. You asked, the next question you asked was, what if the sun was twice the distance away than it is now?
But you said earlier that things continue to shrink. So I said if you double the distance or 8 times the distance, it's gonna keep shrinking. Okay, but here's the problem that you get at. If you 8 times the distance, that's a light hour. Okay, we're told that we're seeing suns that are hundreds of light years away. And we're talking that we can't see our sun at a light hour, let alone a light 15 minutes, okay? So this is where if you believe in light years and stars at these distances, you're just believing. You're believing math. And your thing is, they used to think the sun was the the government scientists used to think the sun was 3 million miles away. Then they said it was 17 million miles away, and now it's 93 million miles away. And the distance of Polaris, or I think it was Polaris, they're guessing between 2 distances, and the difference between that is the distance is so phenomenally obscure. They're guessing. They're making shit up. Okay? I can't remember all of the numbers, but they're so ridiculous. Everything's going around the Great Attractor. If you were going, I think it's at 1,000 miles an hour, it would take like 100 trillion years to cross the face of the Great Attractor. It's utter nonsense. If you look at, the story of gravity, the sun's gravity holding on to the Earth, but the Earth holding on to the moon, and the sun's gravity doesn't affect the moon.
Right.
That makes no sense. Does the Earth's gravity cancel it out? And we're told that the moon's gravity causes the high tide, but a full moon causes a bigger high tide than a new moon. What difference does it make?
What difference does
light? Yeah. And the other thing is, during a full moon, there's 2 high tides. One, because the moon is pulling the water up on the side closest to the moon, and then on the side, the water on the other side of the planet, it's pulling the Earth away from the water. That's the official story. Mm-hmm. That's what you have to believe if you're a heliocentrist. And the other thing is, if the moon was pulling the water, it would make it low tide, not high tide. It would pull the water away from the edges. Okay? It makes the story is heliocentrists don't even know what they believe. You believe, you watch the sunset, that you're falling over backwards faster than the speed of sound. And the reason you don't feel it is because the gravitrons, or whatever they are holding the atmosphere to the Earth and spinning it at all different speeds as it goes higher and higher, faster and faster.
Let me make sure I'm understanding the general point, though. The lunar eclipse and all that stuff can be predicted with the flat Earth model. It's just you two can't do it. Is that correct?
Yeah.
Absolutely. We think that
for
NASA gets it from them. We think that NASA looks back at flat Earth cosmology to predict everything they say happens in the heliocentric model.
So which flat earther can do it?
Catheric device.
Well, one moment. Which flat earther can do it?
Good. I mean, Jaren's probably the best bet, but I don't know if he could like say, yeah, here's the model. Let me show you. Let me pull up a computer program and show you this. But they can because they get how much? 50 million a day to pull up a computer program.
I'll talk to Jaren, find out how.
Put me in touch with him. I'd be happy to talk with him.
Hey, you know what? Wait. A Zedic cosmologist might be able to. What about Bonacci? Do you think he might know? Santos Bonacci?
He knows.
It might take a Zedic cosmologist to answer Darryl's question right now.
Awesome.
That's what I'm thinking.
You can put me in touch with either one of them. But I understand
write it down. Zedic, isn't it? Zedic cosmology.
Well, just like DITRH, they don't know who I am, so I'd be happy if y'all would introduce me and you talk to me DITRH, so you know how I am, we can go ahead and get it going. And let me just ask about the last thing here. About the rockets and the CGI, because I saw your video, DITRH, where you said rockets are either CGI or a certain combination of rocket assistant blimps, the video, and you were mentioning that one rocket about the dust. There was not too much dust, and there was not enough dust and fire, and so on and so forth. So I want to ask about that rocket. What was the exact thrust of that rocket, or if that one is CGI, what would be the exact thrust of a rocket of that size and build were it real?
Well, if the weight of the rocket, what they're telling us is the amount of thrust, I have no idea what the actual numbers are, and you could assign numbers to it. Like I heard Bill Nye say the other day, well, we went to the moon because the amount of fuel in the rocket was the exact amount of fuel that we needed to get there and back for that size of a rocket. Mm-hmm. Well, yeah, that's just math.
This is my concern.
Hang on, let me finish my point. You can tell me your concern.
Okay.
So what is the thrust of that rocket? It's enough to push the smoke away, for sure, below the rocket. It should flatten that entire area. But you see a billowing cloud underneath the rocket when that thrust should wipe everything out for, I don't know, quarter mile, who knows? But the smoke just lingers underneath there. Mm-hmm. I mean, are you watching any of these rocket landings that they're doing where they're landing upright? Mm-hmm. Yeah, and you believe those?
You're buying that, man?
Definitely. But we'll get to that, though. But let me ask you this. Being that you have no idea how much thrust that is or would be.
Well, I'll tell you what. I can answer that. Actually, I used to launch those little play rockets with like the D cell rocket. They're like rockets that are like, I don't know, 2-3 feet tall. Mm-hmm. If it had as much thrust as that smoke would not survive, and it would have blown up more dust. Mm-hmm. And I believe it had a little more thrust than those little toy rockets, because those blew the smoke away amazingly.
But you still don't know exactly how much thrust a rocket like that would have. Is that correct?
You don't really care how much it is.
I mean, this is my concern.
Let's do one point at a time, please. One point at a time. So this is my concern. You have no idea how much thrust a rocket like that would have. So how do you know how much fire and dust will come from it?
Did you know that they have...
I'm talking to DITRH. So how do you know? Because he made the video. How do you know how much fire and dust should come from it when you have no idea? Because the video said...
From experience, knowing how much thrust you need to move a tiny rocket, toy rocket, mm-hmm. All right? The amount of thrust to lift that amount of weight is... It's common sense. I don't know the number. It's 100 million pounds of thrust. I don't know. Doesn't matter. But it's enough to move smoke.
Well,
and it's not moving the smoke.
That settles it for me then. I mean, I understand. Well, we're good.
Well, wait. Let me settle something else for you. The space rockets, when they go up, we've got video of them. We caught them reusing space rocket launch footage from, I don't know, 5 years ago. And then like the next 5 years later, they're using the same footage, mirrored, tinted, cocked a little bit to the side. You got to be like, at some point, you got to stop believing everything they put out. I mean, we were just talking about rockets and the smoke, but look at NASA's moon landing. Look at how they're faking their backflips on their harnesses and getting tangled up. Look at the shadows on the moon. Look at just what we talked about earlier. How is there even shadows on the moon? If it's being lit up, there shouldn't be a shadow there. It's too bright for it to be a shadow. Inverse square law comes into effect, all this stuff. You know, this is, they have great explanations for the stuff that we can observe, and they apply a whole lot of mathematics to it. And that's kind of why I'm like, at some point, you have to look at people like DITRH that are saying, you know what, we hear you. Now, he's got 2 drones now. We hear you. We're trying to put up one with the solar filter, one without. We're testing it. The flat earthers as a community are testing and putting tests together, experiments together that will rival what we are told in the mainstream science. And that's why I'm like trying to get you on board to see you have great questions. This has been proven. We have great rebuttals. We are in the process of creating experiments and doing things that will definitely prove one way or another who's right, mainstream science, or is there something we've been lied to about? That's kind of where we're at.
Another question, like I haven't gotten a good answer from a ball believer, and I have to paint a little picture for you. Actually, I can drop a picture in here if you give me a second. So you got the sun in the middle, and you got the Earth on one side of the sun. Okay, I'm just going to paint a mental picture for you. And you're on, it's midnight, so you're looking in the opposite direction of the sun when you look up. You're standing on the side of the Earth compared to the sun, whatever, and you're looking up, and you see stars, whatever stars you see, doesn't matter. Okay, 6 months later, the Earth is on the other side of the sun. Okay, midnight is facing away from the other side of the sun. Correct?
Yes.
And you look up, and you see a lot of the same stars.
Same ones.
The same ones. And in reality, those stars are on the other side of the sun.
The whole universe, like the other side of the like 100,000 something million miles away, right?
To make sure I'm understanding properly, you're saying that when you're like basically at the equator, basically.
Not even equator.
That doesn't have to do with it. Anywhere. No. You're just looking at the night sky on, let's say it's January, and we're looking at the night sky in January. Now, 6 months down the line, we're way on the other side of the sun, and we're looking here in June. We're looking at a completely
picture in the chat.
There you go. We're looking at we should be seeing a completely different set of constellations in the sky, is what David's going to. But take a look at the picture.
Right.
I see it there.
And they say, in the summer and the winter. In the summer, where there's some constellations that we don't see in the winter, and the reason for that is because in the winter there's constellations that we don't see in the summer. The reason for that is it's darker earlier, and those ones before they spin over the flat Earth and disappear due to perspective, the sun sets in the winter and you can see them. In the summer, it's light longer, so we don't see those early constellations, but those late night constellations, you see them all year long.
All right, this is what I challenge you to do then, because what you're saying does not match what I've seen. For instance, one of my favorite constellations is the Orion constellation. And I know that I only see that constellation around wintertime. And I know that as in the middle of winter, it's like right there. And as winter moves on, it's like to the side and to the side and to the side. And then I don't see it again to the next winter. So in my experience, I see different constellations throughout the year. What you're saying does not match my experience. So what I would challenge you to do is take some kind of photograph or video or whatever and show us a recording of you seeing the same stars 6 months.
That might have been done already. I'll look that up for you.
Yeah, that's somebody's done that. I mean,
and you have to explain why I don't see that, because I only see Orion during the wintertime. I never see Orion like I see Orion like November, December. I never see Orion like, if we look at a calendar, that'll be what, May, June. I never see Orion in May and June. So I mean, you have to first show me evidence of that, and then point out why my eyes don't see that. Because like I said, I have a telescope. I'm a star watcher, and I see different stars throughout the year. I don't see the same stars.
Let me
any of the same stars in the winter and summer, 6 months apart, any time of year, any 6 months. You don't see the same.
I see different stars. Yeah, because the one I focus on is Orion. I mean, it's not like I've looked at every single individual star, right? But I look at the Orion constellation because that's a very prominent constellation. And I mean, what you're saying is every star you see 6 months from 6 months, and I'm saying Orion is very prominent. I only see it during the winter. So, I mean, do you have a star constellation that you've seen? Give me the star constellation. I can tell you Orion.
I don't want to speak without thinking. Let me look it up. I haven't looked in a long time.
Okay, so let me just cover the stuff we'll cover again. So you'll do the solar filter and non-solar filter double drone. I'll do the I don't know how to pronounce it, but that lunar eclipse, right?
Yeah.
And you'll also get what constellations you can see through 6 months apart. Is that correct?
Yep.
Okay, sounds good. So like I said, that doesn't match my experience, and every year I look at Orion because I like it so much, and I only see it during the wintertime. Now, I live towards not on the equator, but towards the middle south of United States. So that's generally, kind of the equator. So, and that's why I was asking where.
Where do you live?
I'm saying we live in the general part of the United States where it's like, not the equator, but it's like towards the belly of the earth. So, when we're looking, that's why I asked, because you all said it doesn't matter what part of the planet that you're on, and I'm fine to have y'all prove that to me. I did hear y'all say that, correct? It doesn't matter what part of the planet you're on, you still see the same stars every 6 months?
No.
Mostly.
It depends. No, like if you believe in the spinning ball Earth.
No, I'm talking about in reality. I'm talking about ball Earth. I'm talking about in reality. Are you saying 6 months from now, I'll see the same stars that I see now wherever I'm at on the planet? Is that what you're saying?
Some of them, yeah. And it also depends on which direction you're looking. Like in the north, you'll see the same stars all year long.
Okay.
Except,
now, I could explain that to you. So my understanding is you're asking that of me as a bald earther. You're asking the why is that? Is that correct?
Because we're looking towards Polaris. I mean, do you believe that when we're 186,000 miles on the other side of the sun, that the axis of the Earth can still line up with Polaris? And I believe your answer is that Polaris is so far away that 186,000 miles doesn't make any angular difference.
I was gonna ask.
No, I'm just saying that's the official story.
That would be my answer. Yeah.
Let me add to that. Let me add to this. D. This is a big thing. Polaris and it staying still. If Earth changes from summer to winter, it has to do a 23-degree axis shift to make summer and winter. Is that right?
You're asking.
The Earth has to tilt in order to make summer and winter. It has to tilt on its axis. That's what we know as creating the seasons. The Earth tilts.
Yeah,
right?
It's already tilted. It's not changing its tilt.
Yeah, exactly. It doesn't.
Yeah,
what he's saying matches what I. Yeah. So
can I ask you a question about seasons?
Okay.
All right. Yeah, you're probably going to get into what I was trying to say.
Yeah.
So the reason I'm asking you and the heliocentric model, the reason that we have summer in our summertime in the north here is because because of the tilt. When the tilt of the Earth has the sun facing directly on the northern side, we have more direct sunlight. So that let's call the light hitting the Earth. Let's say it's like a spotlight. And then when it comes around to our winter, the Earth is tilted, so that spotlight, that circle, now becomes an oval, maybe twice the size. So you've depowered, you've taken the sunlight and spread it over twice the area, and it's not as hot.
Yeah, that's basically it. Yeah.
So that tilt is what causes the seasons.
Yes, that's my understanding.
That's what I was going on.
That spread.
Yeah, the tilt doesn't change, but depending on its location around I got you.
It's not a light per square foot. It gets stretched out in the winter and concentrated in the summer.
Yeah, depending on weather. Yeah, we're on the same page.
This is something I want you to try, and it's gonna take you 6 months to do it.
Yeah.
At sunrise, any day of the year, the sun's angle to where your position is the most severe. It's not 34.5 degrees or whatever it is. It's 1 degree. It's 1 degree, and on June 21st, if I go down to the beach and wait for the sun to appear on a clear day, as soon as I can see the sun, I can feel that heat on my face immediately. I can feel it toasting my face. On December 21st, at the highest point of that day, the solar noon of December 21st, I can stare up at the sun, which is at a much, much, much more direct angle. I'll say it's 70 times more direct. I can't even feel the heat. I can barely feel the heat of the sun on my face. And that's a direct, that's way more severe than the slight tilt that we have between our summer and winter. If that was true, summer and winter, it should be freezing at every sunrise, and at every sunrise, it should be freezing every day of the year. Now, I know that there's some thermal heat, over time because of the direct, but it makes absolutely no sense that the sun rising on June 21st warms my face and the hot solar noon on December 21st can barely feel the heat. And the flat Earth explanation for that, which can be tested in a lab, is that the sun is just closer. It's not the angle. It's the sun is closer to us, and that's it.
Now, one moment. Earlier, you told me that you have no idea where they are or what their position is. They're just luminaries. But now you're saying you do have a distance.
I'll correct that. I don't know the actual miles, but in our model, it's closer.
Okay, like what average miles do you have? Like,
I personally think that the sun that we see is less than 100 miles away.
Less than 100 miles.
Yeah, that's my personal opinion. I'm speaking for no other flat earther. My observations show me when the sun rises, I see it about 65 miles to my east, and when it sets, I see it another 65 miles to my west. From ground. If I go up higher, if I go up with the drone, maybe I see it 100 miles, maybe I don't know. But whether it's 100 miles or 1,000 miles, there's really not that much of a difference in my model. So, but if you had to ask me, that's where I see it.
About 100 miles up.
Yeah, at the most.
At the most.
Yeah, that's my opinion.
Okay.
And I'm willing to change it based on new information. But
as of right now, it's about 100 miles up into the air.
Yeah. Somewhere around there, 100, 250, I don't know.
Okay.
But in the model, the sun is making smaller circles in the north, and that's why if you go into Alaska, like D. Marble did, he filmed the sun circling him without going far enough away to set due to perspective. Yep. And in Antarctica at that same time, it was nighttime, but there's no 24-hour sun in Antarctica, which on a ball model would have to happen. You should have equal, very similar plant life, light, and animal life at equal latitudes, north and south, but we don't see anything close to that. Okay. Have you watched Eric Dubé's video, Antarctic versus Arctic Seasons?
I don't think I've seen that one.
I haven't either.
But I don't want to go too far afield though, like about the sun. And you said you learned that the sun is about between 100 and 250 miles up in the air from looking at it.
No, well, that's my based on all the observations I've seen. And
this is David's opinion. This isn't a consensus of anybody's.
Right, this is my opinion. There's other flat earthers that'll say it's 3,000 miles away. Others will say it's farther. This is my opinion. It's things that you can replicate in a lab. You can't take a distant sun and make seasons on a tilted ball. Okay. You can take a close local sun on a flat Earth and make seasons easily with a close local sun on a flat Earth. You just can't do it on a tilted ball.
All right. So now, given the sun that's between 100 and 250 miles, let me ask you this: what is the shape of the Earth?
The Earth is a flat plane, and we live in a puddle, which is probably pretty circular. Okay. Pretty circular.
When you say a flat plane, you mean like a disc like that?
No, not a disc. Imagine a lake in Kansas. Okay. A big lake, and in that lake are a bunch of islands. Okay. And in the center of that lake, there's a magnetic mountain that is north. So you're on the lake in your little boat, and you hold a compass, and the compass is always going to point to the center of the lake.
But it's an endless plane. It's an endless plane.
No, I'm not saying it's endless. I'm saying you're on a lake.
You know what, David? I think your pizza analogy is much better. The pizza being the middle of the slices being Mount Meru, and the crust being the ice wall. I think it's probably an easier model.
That I don't like that at all. It's a disc. No? That to me is a disc in space. So follow my model. Your Kansas big flat area, and you have a lake, a bunch of islands. Those islands are the continents. The The magnetic pole is in the middle. You're on your boat. You got your compass. You can sail around those islands by going west or east, because west and east are circles.
Okay.
And you always have to correct to the north to maintain the same distance from the north. Okay? So when you're going on a flat Earth and you want to go west or east, when you go west, you have to keep turning to the right. When you go east, you have to keep turning to the left. Otherwise, you're going south.
Around that center pole in the middle.
Point.
Now, given this, understand. Now, given this, you have a sun that's 100 to 250 miles in the air on the plane.
100 250 miles. It's close.
Somewhere around there.
Don't pigeonhole me to it, but I just say it's a close local sun.
Your best estimate is 100 to 250 miles. Is that correct?
No, it's not. I'm just saying that's where. That's a possibility.
That's a possibility. Okay. Well, we know
we
that
see
it's
a
close.
hot spot, though. We see a hot spot from the sun from high altitude weather balloons. That also lends credence to a local sun.
So in other words, but if it's close though, that means. So you're saying that it is moving around, so it could cause daytime and nighttime around the plane. Is that correct?
Sure.
At what rate is it moving? Or what frequency is it moving? Is it moving like each day it moves around once?
Once every 24 hours.
Once every 24 hours. Okay. So pretty much what you're saying is it moves just like how I saw in videos where it shows it moving around the top of the plane like that.
It's like clockwork, very much.
Okay,
clockwork, mathematical clockwork system.
No problem. Now the moon, it also moves around in that same way?
Yeah, the moon's another anomaly. It's more than the sun.
Yeah. Yeah, we don't know what it is. I can't even say if it's a physical object. Some people say they have telescope videos. They see stars shining through the moon, and I have to still look more into that. That's just one of the things I need to now do more research in. But I've not heard that. I've heard that several times. But I just recently had somebody say, no, I have a telescope video or picture, and I could see stars through the moon. So I don't know what is that.
I don't really understand anything, but I just want to make sure I'm trying to just paint a picture of the flat Earth so I can understand it. So I have. The sun is close, maybe 100 to 250 miles away. Let me just make sure I got what I got. We got a flat plane with a pole in the middle. It revolves around. The sun moves around every 24 hours, like in an illustration that Max had. And the moon moves around as well. But you don't. So what's the frequency that the moon moves around?
24 hours and 50 minutes.
24 hours and 50. So you're matching what Max said. 24 hours and 50 minutes. Now, do you agree that the solar eclipse is the moon in front of the sun? No,
not at all. Absolutely not. 100%.
So what causes a solar eclipse?
We don't know. It could be something behind the sun. Imagine. Go back to our room with the blue sheet in it, and we can see the light on the sheet. And between the sun and the sheet on the other side from us, you have something that blocks out the sun. You'll see a solar eclipse on that sheet, but you won't see the object. No one has ever seen the moon with any equipment from any position, not from the space station. They won't show it. From balloons, no matter what. You never see the moon disk approach the sun or exit the sun during an eclipse, ever. No one's ever seen it. You
just see the sun being eclipsed, but you can't see the frickin' moon come in and out of view, no matter what angle you're looking at it. That's the crazy thing about the eclipses that is just anomalous. It's just we don't have a good explanation. And when NASA tried to film it, they had all kinds of trouble trying to live stream this to the world. It was one of the biggest live streams that they could have ever did.
Can you guys see this?
Yes,
I can see
that. I can see that.
Yeah.
Okay. So this is a horrible. I didn't set it up yet. So here you got the East Coast, and here you got the West Coast. Okay, and that the light is over here to the right. And so, as I start going, you see the sun crossing the dome on the east. You see the sun right above the camera there.
Okay.
And then as it goes over, it's now like noon in California.
Okay.
The sun is setting. Okay.
Okay.
East Coast. Look at the shadows coming over the East Coast.
Okay.
And there's the shadow going over Alaska and the West Coast. That's how I see it.
Okay. And to make sure I'm understanding what you said properly about the solar eclipse, using that analogy, what we think of as the sun is the light on the sheet. Is what you're saying, and something could be in between the sheet light and what's really causing the sun. What's causing the sun on the sheet is what you're saying.
Right.
But it's not the moon.
No, definitely not the moon.
Okay.
Doesn't seem to be.
Okay. No problem.
Yeah.
And what causes the lunar eclipse?
We don't know. We don't know. You know, there's ancients that say it's Rahu and Ketu, and you know, there's all of this stuff. We don't know the answer.
And even that's still being looked into. Joey Rocha just talked about that just being a misinterpretation of maybe it's not some kind of disk bodies, Rahu and Ketu. It just could be the point of the moon, the northernmost and southernmost points of the moon could be Rahu and Ketu, but we could have got the misinterpretation there, and now we think it's two disks, creating an eclipse. But Darryl, this is we're still like, this is 2015 that we had a blowing up of the flat Earth. Mm-hmm. We're looking at so much stuff that, we've talked a lot about orbital mechanics, which is incredible. That's the stuff I can't wrap my head around a whole lot, but that's why I needed DITRH to come and kind of talk to you about what he knows. But you know what? I'm looking at the people who told us about the Earth, told us that it was a ball, showed us pictures, and I can go through my whole little rigmarole of how they're faking backflips on the ISS. They're faking pictures of Earth. We just DITRH. Excuse me. Let me finish. No, let me finish. Come on, hold up. I'm not even gonna let Horry finish.
Let me say something.
Candy. I'm not even gonna shut up. I'm not gonna shut up.
I don't really want to talk about NASA.
All right. Goodbye then. Goodbye then. Bye. Because if you ain't gonna let me talk, then I ain't gonna let. I want to say one thing. I want to say one thing because you're running from it. You're running from this. No. I'm not gonna shut up. You gotta take. I'm not even gonna let you finish. That's disrespectful.
Let's go ahead and end, man. I don't really want to talk about
that. Bye. It's been too long. Bye. But you will hear that I feel like, as a friend, as a 10-year friend of mine, you were extremely disrespectful to both me and my other newfound friend in DITRH. Like, for real, I did not talk much at all. But when I did talk, I would like to have been heard, and it was good time. And you cut not only him off several times, but you cut me off as well. And we both agreed in a private chat afterwards that you were just not really, like, listening to what we were saying. And I kind of tried to tell you this when, you tried to tell me about what he was trying to show in his sun drone videos. And I'm like, that's not what he was trying to show. He was trying to show something else. But he was, being attacked by people just like yourself about, oh, well, it's not a proper solar filter. It's not a proper solar filter. That comes into play if you're trying to show a certain thing, but not what he was trying to show. So, I mean, you just didn't listen properly. You cut me off. I couldn't do it no more. And he left. I think he left before you, but no, you left before him. You left, and then he was like, I'm out. And then I was just still left talking on my video, just kind of giving him thanks and just talking about my dismay. But I feel like, dude, this is, you know what? When I told you earlier that my gut was right, this is what I was talking about, D. I'm very, very, very connected to my life, my path, what I'm supposed to be doing, what's truth, what's righteous. And this is exactly why I did. This is what I didn't want to happen. That's it. I mean, you kept really, really, really begging for it, and I kept telling you why I'm cringing about it. That's, how big of a cringe that was for me, man? Really cringy.
Okay, well, thanks for the after party. I appreciate it. You be cool.
That's it?
Unless you have something else. You have something else?
Look at your ego, D.
What about my ego? What do you see?
Like, listen to your attitude. Look at your face. Look how smug you are. Like, you're right. You're higher than thou. And you know what? I put you on a pedestal when I was younger, when we had a friendship years ago. And I really thought that you were doing really proper work, destroying your ego, being like, fair and righteous. And like, I really kind of thought that was like the most important thing. I was like, my boy D has got that in the hat, under his belt. But, the way you've treated me in conversations that have not been recorded, and tonight, which was recorded, but you just treated him more so like that. But even me at the end, like, it's a testament. It's a testament, D, to, no, man, you have a little bit more work to go on your ego and how you treat people. And I hope that you understand that, because I don't really have time for it. You know, I don't have time for this kind of friendship. I don't have time for people with that kind of ego in my life, in my bubble, in my energy at all. So, you know, I would like to watch the video that you do with Anthony Riley if that happens at 5 a.m. And if it doesn't, I just hope that you look into what we're doing and you see that we're the people that are actually doing experimental stuff. We're actually trying to measure it on our own. We're not listening to mainstream science. We're trying to disprove mainstream science and do at many different angles. But if you're going to, you know what, it's a whole lot easier to read a book and repeat it than it is to be on the ground floor and go against the grain. And that's all I'm going to leave you with.
And my understanding is y'all don't want to come back and do the, what did we talk about? The, what was it?
You're really going to ask that question? Let me tell you something. Both myself and DITRH have more class than what we had to deal with in this live stream.
So we're not going to do the double solar filter talk and the solar lunar eclipse talk and the 6 months stars talk.
The answer to that question is I would not be surprised if he said no, because I would just give him a fucking fist bump and agree that it's both a waste of his time and mine.
Sounds
so
good. No problem.
Go ahead and make your videos.
Okay.
Go ahead.
I appreciate it. Bye-bye.
Bye.
Looks like Horry won't be joining in the follow-up talk. I've written to see if DITRH still wants to join. I'll see. And I have a talk scheduled with a flat earther named Sleeping Warrior in a matter of just a few hours. I need to get to sleep. But if I'm missing any references in the video, please let me know. I'll add any more links that I discussed in the video description if I did. And have a good night.